To find a matrix's basic and free variables, we need to know what the pivots are. The pivots are the first non-zero leading entry in a row that has all zeros before it. So in this example, we can see the first pivot in the first row is 1. In the second row, we can see that the next pivot is in the third column, 2, because the second number in the second row is a 0, and pivots are not zeros. And since the number below that 2 is a 0, we know that this is a pivot. And in the third column, the only number that's not a 0 is the one all the way in the right. So that is our pivot as well. Your basic variables are going to be the columns with the pivots in it. So in this case, it would be x1, x3, and x4. The free variables are the ones that are not pivots. So the only one here that is not a pivot is x2. So x2 would be our only free variable. Now with this example, we have this matrix where we want to split the basic and the free variables apart. When we write this matrix out into its respective set of equations, we want to make sure that we have the basic variables on the left and the free variables on the right-hand side. Just like in the very first matrix we saw, we try to find the pivots. So we go row by row. In the first row, it's just the number 1. In the second row, it's the next leading entry, so it's the 2. And in the last row, it's the only entry available, which is the -5 on the right. Now that we have all of our pivots, the only free variable that's left is x3. So now we have our basic and our free variables. Now we want to go to our set of equations and put all the basic variables on the left. Here I marked the basic variables with a red line. We want to put these on the left-hand side of the equal sign. Starting with the first equation, we have x1 plus 4x2 plus 5x3 minus 9x4 is equal to -7. We need to move the free variable, or x3, to the right, so we subtract 5x3 on both sides. Now we have our new equation of x1 plus 4x2 minus 9x4 is equal to -7 minus 5x3. Looking at the second equation, we have 2x2 plus 4x3 minus 6x4 is equal to -6. We need to move the 4x3 to the right, so we subtract 4x3 on both sides. Now for the last one, all the basic variables are already on the left-hand side, with no free variables, so we can just leave it as it is. Now we can start solving the basic variables in terms of the free variable x3. In this case, we can look at the simpler one. -5x4 equals 0. Obviously, x4 is equal to 0. Now we can substitute 0 for x4 in the first two equations to make it a little simpler for us. Next, we can look at the second equation, 2x2 equals -6 minus 4x3. We can divide both sides by 2 to get x2 is equal to -3 minus 2x3. And that is our finished second equation, because the basic variable x2 is all by itself on the left, with the free variables on the right. Now we can substitute that back into the first equation to solve for x1 in terms of x3 only. And this gives us x1 plus 4 times -3 minus 2x3 is equal to -7 minus 5x3. Distributing the 4 gives us x1 plus -12 minus x3 is equal to -7 minus 5x3. Combining like terms and putting all the x3s on the right, we get x1 is equal to 5 plus 3x3. Now that we've solved all of the basic variables in terms of the free variables, we can put it into a new matrix, as you can see right here. We can split this big matrix into two small matrices, one being the constant matrix full of the constants, and the other one being the coefficients that x3 is multiplied by in each row. And now we have the general solution for this set of equations, where you can put any number for x3 and it will give you a valid solution to the set of equations. No matter what x3 you pick, it will always give you a set of values that will satisfy the set of equations.